Hi class, this is Mrs. Snow. As requested, I wanted to give you a short video on bulk properties. And on this arrow, I've added a couple of more bulk properties, including surface tension, vapor pressure, and physical states. So as you're going down through this arrow, you're looking at ranking it in increasing forces of attraction, increasing melting point, or boiling point, increasing surface tension, and decreasing vapor pressure, and physical states of matter going from gas, liquid to solid. Generally, surface tension and vapor pressure are for liquids. So liquids would be substances that are covalently bonded, not ionic, not metallic, nor covalent network, because those substances tend to be your solids. So let's go ahead and look at some of the different trends and review what we've learned in class. So we had this puzzle where we're asked to figure out where to place all of these different types of forces of attraction or chemical bonds. And so here, hopefully you can just follow the arrow. We're looking at ranking this, putting it in ranking order. We're starting off with the weakest on top, and then the strongest force of attraction on the bottom. The weakest are your covalent. So I'm going to start off putting your covalent, polar covalent, and non-polar covalent. But then within that, there are intermolecular forces that apply to polar and non-polar covalent. So I'll save those intermolecular forces for later to rank. But in the meantime, we're going to look at what goes next. What goes next would be your ionic bonding, and then your metallic, and then your covalent network. So the order and ranking of those chemical bonds, starting with covalent, ionic, metallic, and then covalent network. Covalent compounds, the bulk properties are dependent on those intermolecular forces, which are weaker forces than the bulk properties of ionic, metallic, and covalent network. These substances are guided by intramolecular forces. So it's forces that are electrostatic forces that are within the structure versus between the particles. So against the polar and nonpolar covalent compounds are these forces. So nonpolar covalent substances have London dispersion forces, whereas polar covalent have dipole dipole and hydrogen bonding, and also ion dipole force. So this all belongs under the polar covalent. And the ordering is substances that have London dispersion forces have no charge, no permanent charge in their structure. So they're going to have weak temporary dipoles, so London dispersion forces. Then come substances that have charge in their structure, polar molecules. And polar molecules will have stronger dipoles, and so we call those dipole-dipole forces. They're permanent dipoles. And of course, a stronger type of dipole-dipole force is where hydrogen is bonded to a very electronegative element like F, fluorine, oxygen, or nitrogen. And that will cause or produce what is called hydrogen bonding. An ion dipole is when you have an ion and a polar molecule interacting with each other, usually dissolved in each other, and that interaction is called ion dipole force. It's very intuitive. So now let's go ahead and take this idea and let's bring it to putting substances into the mix. So the first thing I do when I have something like this, jigsaw it out, is to actually first pick out the types of bonds. I look at my substances. Now this is not even bonded, it's noble gas. And so I know that it's going to sit right on top there. It's very light gas versus a denser gas, which is carbon dioxide. And they both have what are called London dispersion forces, temporary dipoles that guide why these two substances are gases. Then we go to the next substance. The next substance is a polar molecule, polar molecules. So I'm looking for any non-metal bonded together, looking through my collection, non-metals bonded together. And I find that these three substances are all non-metals bonded together. But I want to order it in such a way that my polar substance, called formaldehyde, CH2O, is up there. And then my polar substances with hydrogen bonding, and I can see the hydrogen bonding right here at the end, would go next. Now the question is, how do I know the ranking order of these two substances that have hydrogen bonding? Well, the ranking order is going to be such that the substance with more atoms in the nonpolar end of these two alcohol groups or alcohols, the more atoms you have, the more likely those London dispersion forces are going to be prominent around those structure or in that structure. So these ethanol has more atoms than methanol, and so you're going to see those forces being stronger between particles than you see in methanol particles. I don't have an example of ion dipole, so we're going to skip that along, but we're going to move down to the next type. So the next one is ionic. So I have three substances that are ionic, and I know they're ionic because they're metal with nonmetal. Now to rank this, I'm going to think about, we have to think about Coulomb's law. So we're looking at force and charge between those two. So the first thing that I want to do is I'm going to start off with my lower charge particles. So here my lower charge particles are sodium chloride and lithium chloride because they both carry a charge of +1 and -1 charges. Whereas magnesium chloride carries a charges of +2 and -1. So between these two substances, I'm going to look on the periodic table and I'll see that between sodium and lithium, lithium is a smaller ion. Because it's a smaller ion, it will have stronger forces, stronger attractive forces between the ions. This is a larger ion, sodium, and so it's going to have weaker. And so the last one of my ionic is a substance that has a really strong charge. And that stronger charge is a +2 charge on the magnesium versus the +1 charges on the other two, sodium and lithium. So now comes metallic bonding, and then comes my covalent network. Okay, so that summarizes what we learned in class. Now we're going to look at some covalent compounds. So I'm going to take out these categories and really focus on these covalent compounds, okay? And spread them out just to give a little bit more room. So again, these two belong under the covalent compounds. So now I'm going to switch it out, and I have these substances. Now to rank them in order of increasing melting point or increasing surface area or decreasing vapor pressure, we are going to need to find out what kind of intermolecular force these substances have. So I really have to target this. They're all covalent because they're nonmetals bonded together. But to target whether something is London dispersion versus dipole dipole or hydrogen bonding is to look to see if the substance is polar or nonpolar. So you'll have to draw the Lewis structure. So in drawing all the Lewis structures, and that will take some time, I will notice that this is a polar molecule. This is also polar. This is also polar, and this is also polar. So they're all polar. So I have no example of a non-polar scenario here. So I'll bring these down to the polar end. And bringing these down to the polar end, I then distinguish them by whether one has hydrogen bonding. This one, if you drew the structure out, formaldehyde, you'll notice that it doesn't have hydrogen bonding. But this substance has hydrogen bonding right here where the OH is. Water has lots of hydrogen bonding throughout its whole structure. And ammonia has hydrogen bonding between the nitrogen-hydrogen atoms. So these three have hydrogen bonding. So now to rank them in the order is to see the structure. Really look at the structure and see if there's any non-polar ends. So I see that there's a non-polar end right here at the CH3. So it's going to have a weaker force of attraction, even though they have hydrogen bonding. This structure has lots of hydrogen bonding throughout. This one also, but this one has oxygen versus nitrogen, and oxygen's more electronegative than nitrogen. So you're going to see a stronger dipoles in here, which means it's going to have stronger attractive forces between particles. And so the ranking order of these four substances would be the following. So you're going to see it increasing in melting point or boiling point as you go down these four molecules. So now we go to our lab. In our lab, we actually looked at these four substances, and we looked at the surface tension of these four substances. I don't have a name for this substance, but it actually is called ethyl or ethyl diol. So two alcohol groups. When we look at this, again, we're looking for, they're all polar substances. Most substances in the world are polar covalent. And so really we don't have to look at the nonpolar substances. Again, we're looking for hydrogen bonding versus dipole dipole. I know hydrogen bonding is when hydrogen is directly linked to oxygen, fluorine, or nitrogen. And so these three substances are hydrogen bonding. So that means this acetone molecule is in fact dipole dipole, has dipole dipole forces. Now we look at these three structures right here. Where I see hydrogen bonding is where I'm going to note which one would have stronger force. The more hydrogen bonding there is, the more attractive forces you will have, because that's where the dipole is. So this substance has hydrogen bonding in the central carbon atom. This substance has hydrogen bonding in the end carbon atom. This substance has hydrogen bonding in both ends of the carbon atom. So this one has lots of hydrogen bonding in its structure. So I'm going to stack it down below. So I'm actually, when it comes to ranking, I'm always kind of like thinking through and puzzling it out and troubleshooting it out. And so my next two substances would be these two. So you have to ask yourself this question. Which one is more accessible in terms of the hydrogen bonding? The OH at the end or the OH that's in the middle of the structure, where there's non-polar ends to kind of obstruct from the interaction from that OH part of that structure. So there's a lot of obstruction here. So I'm going to put it, this is a perfect placement of where the ranking order of isopropyl alcohol would be in this bottom one, because it has lots, this would be perfect because it has a lot of obstruction between the two nonpolar ends. You're going to see this substance to have a weaker attractive force, whereas this one will have a stronger attractive force by comparison. Okay, so here we have dipole dipole. We have all three of these hydrogen bonding. This one having a weaker hydrogen bonding because it has it's obstructed by the two nonpolar ends that you see here. This you have hydrogen bonding at the end with nonpolar ends right here in this alcohol, and then this you have the hydrogen bonding on both ends of this of ethyl diol. Okay, and so this is the ranking order of your polar covalent substances. I hope this helps. Have a good night. I hope to see you tomorrow, and let me know if you have any questions.